3I/Atlas. And as it flew through our cosmic neighborhood, it did something, well, something really weird. It started to speed up, veering off its path in a way that gravity alone just couldn't explain. And that left astronomers with a fantastic puzzle and some pretty wild theories.
So what was the deal? Was this some kind of alien spacecraft with a secret engine, like some people were whispering? Or was it something maybe even more interesting, a kind of natural chemical engine that acts like a giant cosmic handwarmer? Let's dive into the incredible science behind that second idea. All right, so before we get to the really cool explanation, you've got to appreciate the mystery itself. What exactly made this interstellar traveler so strange? Well, astronomers spotted 3 big weird clues. First, like we said, the comet was accelerating in a way that gravity couldn't account for. It had this little extra push. Second, when they pointed their telescopes at it, they saw nickel vapor in its atmosphere, but, and get this, no iron, even though those two metals usually show up together. And third, the gas it was spewing out was mostly carbon dioxide, not water vapor, which is what we usually see from comets. Now, this extra push was tiny. I mean, absolutely minuscule, just a fraction of a millimeter per second squared. But here's the thing. Over the vast distances of space, that tiny constant push was enough to noticeably bend its path. And that was a huge blinking sign that something else, something other than gravity was going on here. So how in the world do you explain this mysterious push? Well, the leading theory is surprisingly down to earth. It actually starts with something you might have in your winter coat right now. One of those reusable hand warmers. It's a fantastic analogy for a really complex cosmic process. The key idea here is a concept from physics called metastability. And look, don't let the word scare you. Just think of a pencil balanced perfectly on its pointy tip. It's stable, but it's not really stable, right? The tiniest nudge and it's going to fall over. It's in a state that's holding on to a bunch of energy, just waiting for the right trigger to let it all go. Kind of like a form of hot ice. You know how a hand warmer works, right? First, it stores energy in a super-cooled liquid. That's a liquid that's below its freezing point but is still, somehow, a liquid. Then you click that little metal disc inside. That click provides just a tiny bit of energy, the nudge. And that's all it takes to kick off a chain reaction. The whole thing crystallizes in seconds, releasing all that stored-up energy as heat. The theory is that this comet has its own chemical version of this exact process. Okay. So that's a hand warmer, but how in the world does a comet build its own chemical spring using the ingredients we know it has out in the freezing cold of space? Well, those clues we talked about, the nickel and the carbon dioxide, they pointed scientists right to a couple of specific chemical suspects, nickel carbonyl and nickel carbonate. Both of these are metastable compounds. When they break down, they release a whole lot of energy. And, this is the crucial part, they release the exact gases that were observed, carbon monoxide and carbon dioxide. And this, right here, this solves one of the biggest mysteries. Why nickel, but no iron? Because it turns out iron just doesn't like to form these specific energy-storing metastable molecules with carbon monoxide and dioxide. But nickel does. So the chemistry itself acts like a perfect filter, explaining exactly why the comet's engine would be spitting out nickel vapor while leaving all the iron behind in the rock. It's beautiful. Okay, so we've got our chemical hand warmers working at a tiny molecular level, but how does that scale up to actually push an entire comet off its course? It's not one big explosion. The idea is that the comet's crust is packed with millions of these little metastable chemical pockets. As the comet gets closer to the sun and starts to warm up, these pockets begin to pop. Each little pop releases a bit of gas, and all that gas builds up pressure inside until it just has to escape out through vents. So you might be wondering, how much of this engine material would the comet actually need? Well, the models suggest that to get the acceleration we saw, about 21% of the comet's total mass would have to be this special metastable stuff. That's a huge chunk. This isn't just a light dusting, it's a major part of the comet's whole structure. And here's the real kicker. This whole process creates a feedback loop. See, as all these pockets pop and vent gas, the comet is losing mass. It's getting lighter and lighter. But the thrust from the escaping gas is staying about the same. And basic physics tells you that if you apply the same force to a lighter object, you get more acceleration. So as the comet's engine runs, its veer actually gets stronger and stronger over time. So when you pull all of these threads together, what you're looking at isn't a sign of some advanced alien intelligence. It's a beautiful, complex, and honestly kind of mind-blowing example of natural chemistry and physics doing their thing. Now, we have to be good scientists about this. It's super important to remember this is a really compelling theory, but it isn't 100% proven fact just yet. The reality is probably a messy mix of different things happening at once. We still don't know the comet's exact mass, for example, and even simpler models, like ice just turning straight into gas, can explain some of the acceleration. It's a great story, but it's not the final word. The big takeaway, though, is this. The comet wasn't an alien spacecraft. It was acting like a slow, kind of dumb, self-destructing engine. But it was an engine built not by intelligent design, but by the random, incredible processes of chemistry and time playing out over millions of years in deep space. 3A Atlas is long gone now. It's already headed back out into interstellar space. But its brief visit might have revealed a whole new class of cosmic object. And it really makes you wonder, right? What other incredible, self-powered natural engines are hiding out there in the cosmos, just waiting to be discovered?